In this lesson, we'll be looking at sketching sinusoidal functions. We'll be looking at these transformations again, so I've put this reference here for you to review, and we're still focusing on the same key values, the A, the K, the D, and the C. And these will have similar impact on sinusoidal functions as they do on other functions. A few key facts to note when we're graphing sinusoidal functions. One is that everything happens in quarters. If you look at this graph here, we referred to this once before when we were solving problems and interpreting graphs. Here we can see the four key values. And if you think about the Cartesian plane work that you were doing with trig functions, there are four quadrants, and on each of the axes there are key values that happen. Either you're on the x-axis, which is 0, or you're at a maximum, or you're back to 0 on the x-axis, or you're down to a minimum on the y-axis, and then back to 0. That's what these key values are here. And so whenever we sketch sinusoidal functions, we'll take whatever the period is. In this case, the period is 12 months, and we divide it into 4 parts. So each of these parts is 3 months. The same is true for any sinusoidal function. So if you look at the parent functions here, to graph these, notice that at 0, you have a maximum for the cos function. At 90, you're on the axis. At 180, you're at a minimum. At 270, you're on the axis. And at 360, you're back to a maximum. So in 360 degrees, you've gone full cycle. And for each quarter, we had a key value happening. And so that's how we're going to be graphing these functions. And just a note here, in terms of the features that we've talked about, in the equation, the amplitude is the absolute value of A. So whereas A may be negative or positive, when we talk about the amplitude, we're just talking about the distance from the axis to the maximum or down to the minimum. The period is 360 divided by K. Also, we can say that K is equal to 360 divided by the period. And the equation of the axes is y equals c. And remember, the axis is the line about which the sinusoidal function goes equally above or below. To begin with, we're just going to focus on transformations and stating those. Right now, this would be a good chance for you to go ahead and see if you recall the transformations, because it doesn't matter which function it is. So you can still refer to vertical stretches and compressions, horizontal stretches and compressions, and then translations using the A, K, the C, and the D. In order to do this, we need to make sure that we have factored out the A value. So I'm going to do that right now. F at x equals minus 4.5, the sine of, I'll divide out 24. That leaves me with x minus, now 2 divided by 24 would be 2 over 24, and if we cancel or reduce, that's 1 over 12. Two over 24. 2 goes into 2 once, and 2 goes into 24 12 times. That's 1 over 12. Now we can state the transformations. 1, there's a negative out in front, so this is a reflection over the x-axis. Looking at the A value here, we know that the This is a vertical stretch by a factor of 4.5. The K value is 24. So this is a horizontal compression. Remember, these have the opposite effect. This is a horizontal compression by a factor of 1/24. A horizontal compression by a factor of 1/24. Looking at the D value, this is a minus, so that goes to the right. This is a phase shift. In trigonometry. Instead of saying horizontal translation, the math convention is that they call it a phase shift. So this is a horizontal phase shift of 1/12 to the right. A horizontal phase shift of 1/12 to the right. Finally, the C value, this is for vertical translations, up or down. This is negative, so it's down, so it's a vertical translation of 3 down. In this next example, we're now going to look at sketching the graphs of sinusoidal functions. So in this question here, we're asked to sketch 2 cycles of the graph of y equals minus 2 cos 1/2 x plus 5. Then we're going to state the domain and range. What we need to start with is knowing what the key characteristics of this function are. So we're going to write down the key features of the sinusoidal function. So the amplitude of this function is 2. Based on the half, we can figure out the period. Remember, the formula is the period is equal to 360 degrees divided by the k value, which in this case is a half. We can divide this on our calculator, or we can invert and multiply. This would be 360 times 2 over 1, or just 2, which is 720. We can also think of this as a stretch horizontally by a factor of 2, where the normal period of a parent function is 360. If we multiply that by 2, that's 720. Now we need to graph 2 cycles of this. What we want to do is, I'd like this to fill up my graph here, so I'm just going to check how many squares there are. 11, 12, 13, 14, 15, 16. So there's 25 squares, so I can work with 24 as a nice even number. And remember, we're dividing into 4 parts. So we're going to craft 2 cycles, that's 8. So we have 24 squares. If we divide that into 8 parts, that gives us 3. So there's 3 squares for every section. I'm going to mark that off now. And when I'm done, I should end up with 8 sections for 2 cycles. And then the amplitude of this is 2. So we have lots of space here. We want to go above by 2 and down by 2, but we need to know our axis. So the axis is y equals, it comes from the c value, that's 5. So looking at this grid, we'll go up by ones. And then I'm also going to go 3 on this side as well. So the period of this function is 720. Looking at 4 sections here, 720 would be there. And then if we go another 4, that would be 1440. Now we have our amplitude, we have our axis, and we have our scale. That's all we need in order to go ahead and graph this. So I'm going to draw a line where my axis is. So that's at y equals 5. 720 divided by 4 is equal to 180. So I will go ahead and label these 180, 360, 540, 900, 1080, and 1260. And then plus 180 would be 1440. Now we can go ahead and graph this function. I'm just going to check whether it's sine or cos. So this is a cos function, and remember, it's a reflection. And so cos starts on the axis at either a max or a minimum. Because it's a reflection, this one will start at a minimum. So our first point would be 2 below 5, and that's 3. Because remember, our a value is minus 2, so our amplitude is 2. So from there, we go to the first quarter, there will be on the axis. The next quarter, it goes up to a maximum, which is 2 above the axis, so that's 7. The next quarter, we go back down to the axis. The next quarter, we go down to a minimum, and we repeat that cycle. The next quarter up to the axis. The next quarter to a maximum. The next quarter back to an axis. And then the next quarter, we're back to a minimum. And then you can go ahead and sketch that in. So there's 2 cycles. I did go ahead and just finish that little bit there to the edge of the graph. Really, there's 2 cycles from here to there. And that's how we graph a sinusoidal function. We've been asked to do the domain and the range of this graph. Even though we only graph 2 cycles, when we're doing our domain and range, that's for the entire function. So for the domain, this is equal to the set of x is an element of R. For the range, that's equal to the set of y is an element of R such that we have our minimum at 3 and our maximum at 7. 3 is less than or equal to y is less than or equal to 7. The next graph that we're going to do has a horizontal phase shift in it. And so this will be the next item that we need to work with. We're going to go through all the same steps again, only this time we're going to graph this graph with everything except the 45. Then afterwards, we're going to translate the graph over to 45. So this will be very similar to what we just did. So a good idea would be for you to go ahead and try graphing this graph without this 45-degree phase shift, and then come back and see how you did, and then you can see what we're going to do to transform it Starting with our amplitude, that's equal to 4. Our period is equal to 360 degrees divided by 3, and that equals 120 degrees. The axis is at y equals -2, which comes from the c value. I'm going to label this graph -1, -2, then this upper scale, once again, we want to do this in segments of 4. In this case, we've been asked to do 1 cycle. Again, we have 24 squares here, and our period is 120, so we need to divide 120 into 4 parts. 120 divided by 4 equals 30 degrees. So we're going to have sections of 30 degrees. We also need to know how many squares that will be. So 24 squares divided by 4 equals 6. So every 6 squares will be 30 degrees. So I'm just counting these off. $30, $60, $90, $120 degrees. And then I'll go back on the other side of the axis. Actually, we don't have 6 squares there, so I will leave that. Now I'm going to put my axis in at y equals -2. Now, it turns out that this goes off the graph, so we're just going to come down here. Actually, I'm going to add in another line down at the bottom here. So graphing this line, it's a sine curve. Sine starts on the axis, and this is not reflected, so it's going to go from the axis up to a maximum. Sine starts on the axis at -2. At the next quarter, we go 4 above the axis, which would be 2. At the next quarter, we're back to the axis. Next quarter, we're going 4 below the axis. And next quarter, we're back to the axis. Now we can sketch this in. And that's 1 cycle graphed without a phase shift. In order to do a phase shift, we need to move this 45 degrees to the left. We need to know how many squares is 45 degrees. 6 squares is 30. That means that 3 squares is 15. So 6 is 30 plus 3 more makes 9 squares for 45. So we need to be able to have 9 squares, so we'll start with this point here. 1, 2, 3, 4, 5, 6, 8, 9 squares. So this would be graphed right here. And then we do that with all the points. And this point here, 1, 2, 3, 4, 5, 6, 7, 8, 9. And finally this point, 1, 2, 3, 4, 5, 6, 7, 8, 9. Now from here, we don't have a full cycle. So what we can do from here, we know that it's 6 to a full cycle. So we will go over 6 and know that we will be at a max. 1, 2, 3, 4, 5, 6. And at that point, we will be at a maximum. And now I can go ahead and sketch this in. And now we have one cycle of this graph sketched. And now we just need to do our domain and our range. Once again, our domain is x element of R. And that will be true for all sinusoidal functions except in an application where it may stop. For example, if the x-axis was time, we don't go below 0 in time. But in general applications, domain will be an x element of R or general graphs. And the range, again, is defined by the max and the minimum. So the set of y is an element of R such that -6 is less than or equal to y, which is less than or equal to 2. Now at this point, you could go ahead and do this next graph on your own. And once again, this has an opportunity for you to practice doing a phase shift. Then come back and see how you did. So looking at this graph, it has a reflection and there's no value except 1 understood here. So its amplitude is 1. The phase shift for this graph is 180 to the right. The period is equal to 360 divided by 1/3. And that would be 360 invert and multiply, so that's times 3. So that would equal 1080. Once again, we were asked to graph one cycle. In order to graph one cycle, I need to know that first of all, that the axis is y equals 1. And then I'm going to take the period, which is 1080, and I will divide that into 4 parts. That gives me 270. And once again, because I'm dividing by 4, just like the other question, we're going to have 6 grid spaces represent 270. So I'll go ahead and do my axis here. These quarters are 270, 270, 540, 810, and 1080. Now I want to label my axis. Our amplitude is 1, so in this case, because it's 1, I'm going to use 4 grids for that. Otherwise, it'll look very small on my graph. So every 4, so this goes up to 2, and then we have 1 and -1. Now I'm ready to put my line in for my axis. So my axis is at +1. looking at my equation, this is a coast curve and it's reflected. That means it's going to start at a minimum. So it will start at 0. The next quarter, it will go up to the axis. The next quarter, it will go up to a maximum. The next quarter, it's back to the axis. And the next quarter, it will be at a minimum. Now we simply need to do a phase shift 180 degrees to the right. So we need to know how many grid spaces that is. So first we need to know what each of these squares is equal to. So let's take 270 and divide it by 6, since there are 6 squares here. And that's equal to 45 degrees. Now we need to move 180. So 180 divided by 45 is equal to 4. So we need to move this graph 4 spaces to the right. So we'll start with this point here. Four spaces to the right, and then we'll do all of them. I'm translating them all 180 degrees, which is 4 spaces to the right. And then once again, I can't move this last point here. So I'm going to go to this point that I have, and I'm going to take it one more. So it's at its minimum. And so if I go 1, 2, 3, 4, 5, 6, it will be back to the axis. So what we have is this curve here. And so this is the sketch of this graph now. And then finally, we need to know the domain and the range. The domain, once again, is equal to the set of x as an element of R. And the range is equal to the set of y as an element of R, such that the minimum value is 0 and the maximum value is 2. 0 is less than or equal to y is less than or equal to 2. And now you can go ahead and practice these.